Hi guys, this is the 2.3 translation of a function. Translation means you're moving sideways or moving up or down, okay? You're not changing the shape of the graph, you're just moving. So if you take a look at this lesson, let's try to graph this by making a table of values first. So we have f at x equals x squared. So I'll just put it as a x squared here. And then I'll make it thinner. So then all you have to do is plug the x value from -2 to 2 into the function and then find what the value is. So this becomes 4, 1, 0, 1, and then 4. So hopefully you're okay with that. Now the rest, then we just have to plot the points and then we should be okay. So we have these 5 points and then we draw a nice smooth curve. Now my curve looks very horrible, so I'll try to redraw it. Slightly better, and then do the same thing on the other side of the graph. So we have a smooth and nice curve. So we have a parabola. Okay. Now we're going to use this parabola to investigate how the translations work based on what function you have or what components you have in your function. So let's take a look at the first one. It says consider the function f at x plus 3. In other words, f at x was x squared, so x squared plus 3, right? Now this basically means that you're adding whatever the y value of the original function by 3 because you're adding 3 to the whole thing. So as I said, f at x plus 3 becomes x squared plus 3. Now we know that the x squared was negative, well, x squared when x equals -2 was 4, so we have to add 3 to that, and then 1 plus 3 to that, 0 plus 3 to that, 1 plus 3 to that, and then 4 plus 3 to that again. So that becomes 7, 4, 3, 4, and then 7 again. So we're okay with this? Now I'm going to graph this. I'm going to plot this using, let's say, red. I don't know why I use blue and then red here. I'll just change this to red. So let's plot this when -2 is the x, the y is at 7. So it's right here, and then it's right then it's at 4, and then it's at 3, it's at 4, it's at 7 again, so it looks like this. Okay, so as you can see, the whole graph actually shifted up. Now, how much did it shift? If you compare the vertex, it actually was at 0, now it's at 3, so it moved up by 3. So whenever you're adding or subtracting to the whole function at the end, or outside of the function, that changes your y value, meaning it changes the location vertically of your function, okay? Now, next one, I'm going to use green so that we can actually distinguish this. So if you take a look at the next one, we have f at x minus 2 instead of f at x. So this means that you're subtracting 2 from the x value that we used before, right? So this basically means it's x minus 2 squared, not x squared minus 2, okay? The x squared minus 2 should look like f at x minus 2, okay? So two things are different. Be really, really careful with it. So this is f at x minus 2, so x minus 2 squared. Now on your sheet, it should have negative to negative 1, 0, 1, and 2, okay? So what we're having here is then -2 as the original x value, and then minus 2 squared, which gives me 16. Okay, that's because it's -4 squared, and that's why it's 16. Now, same thing goes. It is -1 minus 2 squared, and that gives me, -3 squared, so that is 9. And then the next one is 0 minus 2, and that's squared, so that is 4. And then 1 minus 2 squared equals -1 squared, which is now 1. And then we have 2 minus 2 squared, which is now 0 squared, which is now 0. Now, it seems it's only covering the left side or the right side of the parabola, but we'll see it, okay? So if you plot this, when x equals -2, it's at positive 16. The graph doesn't, or the grid doesn't have 16, so we're going to skip. Now, when the x is -1, it's at 9. Now, when x equals 0, it's at 4. And when x equals 1, the y value is at 1. and then when x equals 2, it's at 0. Now, as you can see, this is a parabola, right? We're dealing with a parabola, so it goes back up here if you keep making the table, and it goes back up, and it goes back all the way up. So if you take a look, this is my green function, okay? So this is my green function. So you're comparing the blue to the green now, okay? You're comparing the blue to the green. Now, if you look at the blue and if you look at the green, what's happening is that, especially looking at the vertex, it's moving to the right by 2 units. So if you take a look, inside we have a -2, right? The -2, if you see -2 inside, apply directly to the x in terms of addition or subtraction, it moves the opposite way of the number that you see there. So I have -2, meaning instead of moving to the left, you move to the right by 2 units, okay? But in a more formal way of saying it, we have to acknowledge it this way. So y equals f at x minus p, okay? So it was before x minus 2. So in this case, for the second example, it was p being 2, okay? So as p being 2, a positive 2, we move to the right side. Now, in a simpler way, if you have subtracting, that's moving to the right, okay? Inside of the brackets, it moves to the right. So if the p, then the p is a horizontal translation. If the p value itself, okay, is greater than 0, it moves to the right. And then if the p value itself is less than 0, it moves to the left. And the same way, if the q is the vertical translation, and if the q is greater than 0, it moves up, and if it is less than 0, it moves down, okay? Now, so the next one we have f at x plus 2. So we're basically just describing the transformation of this. Again, we have something inside of the brackets. So basically this does the horizontal way. So we have horizontal translation. Now we have plus 2 inside of the bracket, so it should work the other way around. So translation to the left, okay, remember this, to the left by 2 units. Or simply you can say move to the left by 2 units, okay. Again, that's because you have positive 2 inside of the brackets. And in terms of the notation that we used here, it's basically x minus -2, and that becomes x plus 2. Now, then the next one, we have f at x minus 5. So this is outside of the brackets or outside of the function itself. Then it obviously is a vertical. Okay, so it is a vertical translation. Now, vertical translation down by 5 units. And that is very simple because it is -5, right? If it was +5, it goes up. Or you can simply say move down by 5 units. Okay, so either I will take it. Okay, either I will take it. I prefer the first one since you're a grade 12 teacher. May prefer the proper way of saying, which is vertical translation or horizontal translation. But for now, I am okay with either of. Okay. Now then, if you take a look at the last one, we have horizontal translation to the right by 3 units. So hopefully you get used to this, right? We have a -3, meaning you're moving to the right. And then we have vertical translation vertical translation up by 2 units. So hopefully you're getting the idea of how the translations work or can be identified by just looking at the function notation itself, okay? So then let's flip to the next page. Let's flip to the next page. We have a little more work to do here. So this one I actually want you to go through with me for the first 2 or ish, and then rest, we will actually talk about it later, okay? Now, here for the transformation wise, I just want you to talk about the translation. I don't care about the stretches or compressions, so I just want you to talk about the translations, okay? So the first one says it shifts 5 units down. So it means f at x minus 5, right? And obviously that tells me that y equals x minus 5. Now the next one says 3 units up and 9 units to the left. So left means x minus 9? No, it's x plus 9. Remember, it works in the opposite way. And then it says it shifts 3 units up, so plus 3. So then in this case, my function is negative 2x, so y equals negative 2. Now it has to be directly done to the x, so x plus 9, and then you have plus 3 at the end, okay? Now next one, then we have f at x. Now it says units down, 5 units down and 2 units to the right. So units to the right, 2 units, that means it's negative 2 because you're moving to the right. And then you have minus 5 because you're moving down. Now in terms of the actual function, then y equals x minus 2 squared and then minus 5, right? Now next one, we have shifts 4 units to the left. So we have f at x plus 4 because you're moving to the left, and then unit 1 up, so plus 1. The actual will be y equals square root of, then x plus 4 instead of the x, and then plus 1 outside of the function, okay? So what I want you to try, and then we will actually take this up all together in class, is I want you to try these 4, okay? So I want you to try these 4, and then we'll take it up in class, okay? Now, then let's take a look at these. So it says, describe the corrected transformations. Well, let's say, well, forget about the right correct function equation for now. Okay, we're not going to worry about this one for now. Just to focus on the describing corrected transformation of the f at x. Okay, so let's take a look at the first one. The f at x is the green one. So this is the original one. Now I want you to find how the transformation was done on the blue one. So then if you take a look at it, in this kind of cases where you look at the graph, all you have to do is you look at, or you choose a point, just a 1 pin point. So in this case, I'll choose this point, okay, just a random point on the graph. Now then on the blue, where that exact point happens is right here. So it shifts to the left by 2 units. So what happened for the blue, I'm going to use blue color for this. So what happened to the blue is that it's f at x plus 2, okay, because it moved to the left by 2 units. Now next one is the red, so I'm going to use red for this. Now same, because it moved this way to the right by 2 units, so it should be f at x minus 2. The f didn't move up or down in terms, well, for the blue or the red, so it only has the horizontal translation so far. Now then let's take a look at the next one. We have the blue one as the parent function. Now then we have the green one as your transformed function. So when you do these, try to find the description of the transformation, you just need to choose a point. Now in a parabola, the easiest point is your vertex. So vertex was at 0, 0. Now it moved to, let's say it's 1, 2. So in terms of the y value wise, it increases by 2, so meaning it's up by 2, right? Up by 2 units. And then, oh, by the way, and then it moved to the right by, so right by 1 unit, right? These are the descriptions. I forgot to do the description on this, on the first one, but I'm pretty sure you can figure this out because I said that already. So then the function wise, it's basically just f at x minus 1, right? Because it is 1 unit to the right, and then plus 2 because it moves up by 2 units, okay? So it wasn't so bad, right? You choose a point. So remember this, choose a point on f at x, the original function, and find where that exact point is moved to the new function, okay, new function. Now that's when you have translations, okay? If you have If you have stretches or compressions, it work slightly differently. Okay, so be really careful with it. Now, last page and the last two questions, same thing. So if you take a look at it, the first one actually has a 0, 0 as vertex per se, and then it moved to this one. So it moved down, so by 1 unit, and then moved to the left by 2 units. Now again, your grade 12 teacher may prefer the horizontal translation and the vertical translation. Okay, so this one has vertical translation down by 1 unit and horizontal translation to the left by 2 units. Now, having said that, our then function will be x plus 2 and then minus 1. Okay. Now, then the last one, so this one I actually want you to try it at home, and then we'll take this up all together. Okay, so we're graphing this. So we have f at x looking like this, and then we have f at x minus 3 minus 2. This is not an easy question, but it's not a hard question either. So try this one out, and then we will take up these questions in class on which day? Thursday. Okay, I will post our homework questions on the Facebook page as well. Okay, thank you for watching. Bye guys, see you in class.